the one basis that you can have is a set of all impulses that occur at every point. I can take Dirac delta at every point here. So if I have to express this trajectory, yeah. So suppose I have f of x. Suppose I have x between a and b. What is f of x equal to?
So in terms of Dirac delta.
Yeah. So in terms of Dirac delta, what is f of x equal to? So I'm just trying to prove that Dirac delta at every point is a basis for this. Yeah. So you need two things, right? If you want to say it's a basis, you need three properties. First is if I look at all Dirac delta that lie between a and b. I look at Dirac delta distributions that lie between a and b that are defined. So I have stuff like delta t minus a to delta t minus b. So these functions are going to be deltas that peak between a and b, right? Delta t minus a to delta t minus b. So I can have delta t minus x where a less than x less than b. So I'm looking at all these functions. Delta t minus x where a less than x less than b. Yeah. So now I want to see whether this forms a vector space. This forms the basis for this vector space. The set of finitely supported trajectories. Now suppose I want to say that this forms a basis. How can I say it forms a basis? Firstly, it should lie within this vector space. Do these distributions lie within this vector space? So how did I define this vector space? It should take zero value outside the interval a to b. So for all these Dirac delta distributions, it takes zero value outside a and b. Satisfies this, right? Done. First condition satisfied. Second, they should be linearly independent. Can I take a summation of any of these to give you 0? Can I take a summation of any of these to give you 0? I can take linear combination of these. Can you get 0? So long as they are different points, you are not going to be able to. So you are just going to add. So if we look at these trajectories, if I have one Dirac delta at one point and another Dirac delta at another point, I cannot have any non-zero linear combination of these two that gives you the 0 trajectory, right? Correct or no? So these are linearly independent. Third thing that you need to say is they span the whole space. Now, do they span the whole space? So how can I prove that they span the whole space? Now, what I know is that, so what is the component of, suppose I have a trajectory f of a